All right, this is Coach Ledbetter. This lesson's over solving equations with variables on both sides. Okay, so what we're going to do is, if you notice here on my paper, I have an example here. You see the equal sign. The equal sign's like the net on a tennis court. All right, so you see the net on the tennis court. Okay, so you remember there are if you ever seen anybody play tennis, they have usually you have the professional serve where they throw the ball up in the air and they hit it really hard, and they always grunt. You go, oh, like as they're swinging and hitting the ball. And then you have the big fancy serve, the professional serves or the hard serves are like one of the variables. So you have the 5K and the 3K. Those are like the fancy serves. Then you have the little numbers, the easy numbers, the simple numbers. And the simple numbers remind me of the simple, hitting the ball over. I'm gonna have to pause it. I'm receiving a phone call. All right, sorry about that. Anyway, what we're doing is we're pretending like this is the net of a tennis court. And so we said there's two types of serve. There's the professional serve, which is the ones with the variable, and then there's the easy serve. The easy serve is one where you drop the ball and you just underhandedly just hit it over to the other side. All right, and that's the simple numbers. So it's a simple serve. All right, so you have a choice. You see the equal sign here? So the equal sign, you have a choice of which serve you're going to hit to the other side. And just like in tennis, if I hit the hard serve to one side, the other side has to hit the easy serve to me. So here's how it does. What I normally do is I like to move the numbers first. All right. So like I'm going to move the 2 because it's a plain number. So I'm going to hit the simple number over here. So here's the equal sign. Remember, here's the net right there. All right. So this is a positive 2. So I want to subtract 2 to both sides. All right, so once I do that, this becomes a 0 pair. I bring down, my pen's not writing. I'll bring down the 5K. Bring down the 3K. And then -6 and a -2. Remember, if 2 negatives, that means you add them, but the sign's negative, so it's subtract 8. All right, now that we hit the 2 over there, think of tennis. You hit the 2 over there. Just like in tennis, the next person is going to try to hit the ball back, but this time he's going to hit the letter. All right, so if I serve you the simple numbers, you got to serve me the Ks. So I'm going to do the opposite to both sides. So since I'm going this way, this is a positive 3K. So I'm going to subtract 3K to both sides. $5K minus 3K is 2K. Let me put an equal sign here. This becomes a 0 pair, and we bring down our -8. Now it's just simple like we've been doing one-step equations. What's my variable? My variable's K. What's being done to K? It's being multiplied. What's the opposite of multiply by 2? We're going to divide both sides by 2. And you can see that K is going to be K 2 divided by 2, which is 1. K equals a -4. Now, I got K's -4. Let me show you what happens. If you have the right number and you plug these in, I'm just going to rewrite the original equation. All right, so there it is. Now, wherever there's a K, I'm going to put a -4. So I'm going to rewrite this, but instead of K, I'm substituting a -4. So here we go. Try different colors so something that stands out a little better. I think that works. All right, so here we go. And then you do PEMDAS. So 5 times that's a -20. So it's like 2 minus 20. And this side here, you got to multiply this. So it's -12 minus 6. And you can see both sides equal -18. All right. So that means that if we use -4, both sides are going to be equal. So see, that's what we're doing. We're trying to find what number we can put in for K that'll make both sides equal. And you can see -4 works. All right, so let's try another one. Try example 2 here. All right. So we're right back to the tennis court again. And if you look at it, this is my net. Now, I got to figure out which one I want to hit where. So otherwise, where do you want your W's and where do you want your simple numbers? Well, if you look here, you have a W on this side of the tennis court, or the wall, if you want to call it a wall. And there's a W over here. So you got to move the W's over. So I'm going to hit the ball to the opposite side of the tennis court or the wall, whatever you want to call it. I like calling it a tennis court. So if you hit the ball, now think about it, when you hit the ball to the opposite side, you do the opposite to both sides. So if that's a plus, I'm going to say minus. The opposite is minus. Now, do you know why I did not move the 2 to the other side? Because there's no numbers over here. It's just 7W. So I'm going to move this W over here because this number is fine. See how the 8 over here was by itself? I mean, that's what we want to do. We want to get the number by itself and the letter on the other side. So here we go. This is 0 pair. Bring down my 2. 7 minus 3 is 4, and it's a W. Now I divide both sides. Look at your variable. What's being done to your variable is being multiplied by 4. What's the opposite multiply by 4? Divide both sides by 4. 4 divided by 4 is 1. 1 times W. So actually W equals, and what's 2 divided by 4, what you should say is 1/2. So W is 1/2. Again, I can put it right back in the equation. So I'm just doing this one more time so you can see it. So wherever there's a W, I'm going to put 1/2. All right, so this is going to be 3/2 plus 2. This right here is going to be 7/2. I say 7/2. I don't know what I'm thinking. My goodness, 7/2. 7 1/2. All right, 7/2. All right, this is 1.5 plus 2, which is 3.5. If I divide 2 into 7, I get 3.5. So it checks. All right, so that'll be the last one I kind of check. I just want to show you how it works. All right, so we're going to just do a couple more examples. We've got quite a few different examples. And so I've got quite a few that I want to show you how they work. All right, so here's one that's is a really good one to learn. All right, so I'm going to put this one on here. Example 3. I think I moved my paper and it messed up. All right, so here we go. Watch this. X divided by 2 plus 1 equals 1/4 X minus 6. All right, so this one has fractions. You see other fractions? So there's a couple of things that I like doing here. The first thing is I like to find and multiply the common denominator. All right, so we're going to find the common denominator. So if you think about all these, I mean, that's really over 1, and this is over 1. So now they look like all fractions. What is a number that I can make all 4 of these? What's the best number I can make out of all of them? I can make this on a 2. It's a 2, so I can make that a 2, but that's a 4. I can't make it into a 2. All right, so let's try 4. Can I make that in 4? Yes. Can I make that in 4? Yes. That is already a 4, and I can make that a 4. So my common denominator is going to be 4. Now watch how I do this. The way I do this is very helpful. Excuse me. I'm going to take my common denominator 4 and I'm going to multiply it to each term. All right, now watch. 2 goes into 4. So I'm dividing. See, this line means divide. So 2 goes into 4 2 times. And then take that 2 and multiply it to x. So my first number is going to be 2x. Again, watch. 2 goes into 4 2 times. And 2 times x is 2x. All right, 1 goes into 4 4 times. So 4 times 1 is 4. So this is a plus 4. 4 goes into 4 one time. So 1 times 1 is 1x. 1 goes into 4 4 times. So 4 times 6 is a negative, and it's a negative, it's 24. So now we don't have any fractions. And so now we can figure out a way to do this by doing the same thing we did before. We think of a tennis court. So there's my net. I want to move the numbers over here and the letters over here. I just like doing it. I like my letters over here. So since it's a +4 and I want to move it to the opposite side of the equal sign, I'm going to subtract 4 to both sides. All right, I'm going to bring down my 2x. Bring down my x, and I'm going to put 1. This is 1x. I'm just putting x here. And 2, negative 24 and a negative 4. Remember, 2 negatives when I'm adding, or 2 negatives means I'm going to add them, but I'm going to keep the sign. So it's a minus 28. All right, now since I hit the number over here, now I'm going to go with the letter this way. And so since it's a positive x, I'm going to make a negative x out of both of them. 2x minus an x. So if you have 2 x's and I take away an x, you only have 1 x. 0 pair, and this right here is a minus 28. There's my answer. Let's try example 4. I'll do it in a different color so it stands out from the other one. All right. This one is similar to the fraction, but it's decimals. So how can you do decimals? All right. Decimals. We don't want decimals. We want all whole numbers, just like the fractions. So with the fractions, we found a common denominator, multiplied it by that common denominator, and we noticed we didn't have any fractions. It was easier. So here we don't want decimals. So find the highest decimal place. Otherwise, what can I multiply to all these to make them whole numbers? Well, that's 10. See how that's 10th place value? That's a 10th place, and that's a 10th place. So why don't I multiply everything by 10? If I do this, it'll move the decimal place. So if you take 1.3 times 10, it's going to be 13c. If you take 10 multiply to 3.3, it's going to give you 33. You multiply 10 to 22.8, it's going to give you 28. And see, now you don't have any more decimals. And it's the same principle here. See, now look, I got a simple number here, and I got a number with a coefficient here, and a number with coefficient here. So I want to put the C's together. So I'm going to take this 33, and here's my wall. So I'm going to hit it to the opposite side. And since this is a positive, I'm going to subtract 33c to both sides. 13 minus, remember this is a plus. So plus and minus means subtract. So this should be a negative 20c. That's a 0 pair. And this is 28. Now, I'm going to look at my variable. My variable is a c. What's being done to c? Being multiplied by a negative 20. The opposite of multiply is divide both sides by negative 20. This will make 1, and 1 times c is c. And now look, this one's going to be 28. It's actually a negative over 20. I can reduce this. And so if I reduce this, let's set, sorry, my throat is really messed up. Sorry. C, I can divide both of those by 4 because 4 goes in that 7 times and 4 goes into 25 times. So my answer is a negative 7/5. Now, we can leave it like this. We could put it in decimal form or a mixed number, but I would prefer it to be just a simple a simple improper fraction. You don't have to go and make a decimal or anything like that. Just leave it as an improper fraction. All right, so we're going to talk about the distributive property for a little bit before we start mixing them in with variables on both sides. So if you look, we have a number outside the parentheses. There's no operation between them. There's no minus or plus between here or divide. So when you see these two side by side, it means multiply. So we're going to distribute. And we talked about this many times. So we're going to take this 3 and we're going to multiply it to everything in here. So I always tell my class that this parentheses is like a room. Think of your room. And everybody in the room, we're going to distribute a 3 to. So everybody's going to get a 3. So think of everybody in your room. They're going to get the number 3. So 3 times 2, and we multiply, is 6, and the x stays with it. 3 times a -5 is a -15. All right, so that's distributed. I can divide 3 out of both of these. So let's do a couple more. And I just want to practice the distributor. So let's say that we have, that's one example. Let's say we have another example. Let's say 2x, x plus 3. All right, so now this is the letter x, not times. Even though they're side by side, this whole thing here is going to get distributed to everything. So 2x times x. So I got a 2 because that's a 1. So 2 times 1 is 2. We have 2 x's. All right, so we have an x here and x here. So that makes it x squared because we're multiplying variables. Then 2 times 3 is 6. And you have 1x here. So we're going like this. See this? So we're going 2 times 3 is 6, and it has 1x on there. All right, so that's how that one works. But what if you had something like this? What if you're distributing a fraction? Well, I can show you a shortcut way. These are kind of nice. You could do 2 times 3 is 6, then divide by 3. So you go again, 2 times 3 is 6, divide that answer by 3. Okay, which is 2. You could also do this. This means divide. So 3 goes into 3 one time. 1 times 2 is 2, and there's an x on it. All right, so we did that one. Now we're going to go to this one. Go to the 9. 3 goes into 3. 3 goes into 3. 3 goes into 9 3 times. 3 times 2 is 6, and it's a minus, so it's a minus 6. All right, see how that works? All right, so what if we had a variable on both sides that had some stuff like this? So we're going to do an example. So I'm going to write it out here. All right, so here we go. So you notice the parentheses, so you know there's probably going to be a distributive property here going on. So we're going to start with this side. So 6 times 5m. 6 times 5 is 30, so it's 30m. Then 6 times a -3 is -18. So see, distribute 6 times 5 is 30. There's an m left over. 6 times a -3 is a -18. Now let's do 1/3. So I'm going to take 1/3 times 24. So remember the little trick here with fractions like we did here? 3 goes into 24 8 times. So 8 times 1 is 8m. 3 goes into 12 4 times. 4 times 1 is 4. Now we have our variables on both sides. We can play our little tennis match now. And so remember, this is, and I'll try to do a different color. Here, let's do green. Green is our tennis court net. And so I like moving the numbers over here first. So if this is a -18, I'm going to add 18 because I'm hitting the ball to the opposite side. bring down my negative, or not negative, bring down my 30m. This is a zero pair. We have an equal sign, 8m, and then add is 22, because if you add those up, you get 22. All right, now that we hit the plain number over, now it's time to hit the letter to the other side. So now we're going to take this 8m and we're going to hit it this way. So the opposite of plus 8m is minus 8m. And we're going to do that on both sides of the equal sign. So here we go. 22m equals 0 pair plus 22. Now look at there. That looks like it's going to be pretty easy. What does m equal? Well, you should be able to figure out. M is your variable. It's being multiplied by 22. So you can divide both sides by 22. So m is going to equal 1. So there we go. M equals 1. All right, here's example 6. Now notice this one has parentheses, and it's got something a little bit extra back here in the back trying to hide out here. So first thing is we're going to distribute first. So if you see a parentheses, always distribute first. So let's do that first. 5 times x is going to be 5x. 5 times 1 is going to be 5. All right, we got our equal. 3 times 5 is 15. There's an x with it. 3 times a negative 4 is a negative 12. And then you have this guy in the back. He's a negative 10x. All right, so after you do that, notice what you have here. You have a number and a letter. And here, I'm sorry, a letter and a number. A letter, a number, and a letter. So you have more than 2 things here. All right, so that means you're going to have to combine like terms. So we're going to have to combine these guys, this guy here and this guy here. That's what we're going to have to do first. So here's what it's going to look like. 5x plus 5 equals, I'm going to combine these two. So 15 minus 10x is 5x. Notice I'm putting that in green so you can see it a little better. And then minus 12. So see these two, you have to watch the sign, but that's 15 minus 10, that's 5x. And this just should bring this on down. Now you have the same song and dance that you have before, like even if we had the top. So here's what we're going to do. Same thing as always. We're going to move the number over. Bring down my 5x here. And then negative 12 and negative 5 is a negative 17. All right, now we're going to hit the letter to the other side. There's a positive. All right, so I'm going to subtract 5x to both sides. And look at here. Look what's going to happen. 5x minus 5x, that's 0. And the reason why we're putting a 0 because there has to be a number over here because there's an equal sign. So 0 equals something. All right, and so 5x minus 0. So this is 0. This is a 0 pair, but we don't need to put 0 here. We can if we want to, and let's go ahead and do it so you can see what I'm doing. All right, so you see there? So 0 minus 17. So really, it's 0 equals minus 17. Do you notice our variable's gone? We don't have any variables. Notice what it says. 0 equals a negative 17. This statement is what we call a false statement. We cannot, I mean, think about it. Does 0 equal negative 17? And you should say, no, it doesn't equal negative 17. All right. And when you see this situation, this is a special case. It's one of those special cases. All right. So this is a special case. It does happen. All right. When you have a special case like this, when the variables have canceled each other out, and you have 0 equals a negative 17, and or not just 17, if it says 0 does equals a number and it doesn't, so otherwise these are different, we say this is a no solution. All right, and no solution means none of the answers will work. So like we can pick any number. You can pick any number, negative, fractions, positive numbers, any number, and you can plug it in here in any of this. This side will never equal this side. It'll never happen. All right. And so it just, no matter what number you pick, it just will not work. All right. And I can show you. I can actually take one, and we're going to take one. Let's take, and I'm just going to fill it in here. Let's see what number. Let's just pick number 2. All right. So we're going to pick 2. So I'm going to take this and watch over here. I'll say 5, 2 plus 1 equals 3, 5. And that's a little 2 because these two are going to get multiplied together. Minus 4 minus 10 times 2. All right, so I'm just cleaning it up. 5, that's 3, equals 3, that's 10, minus 4. I forgot to put the parentheses here. All right, parentheses, and then this is going to be minus 20. So all I'm doing is just doing the math work. 15 equals, this is 3, that's 6, that's minus 20. 15 equals 18 minus 20. 15 equals negative 2. And 15 doesn't equal negative 2. I think I messed up my math somewhere. That's 6. So that's 10. That's 6. That's 18. Oh, yeah. And that's 2x. I put 10x. Okay. So you can see that doesn't work. 15 does not equal negative 2. All right. So that's how it works. All right. So let's do another one. Doing a lot of examples for these because there's so many different situations that could pop open. I mean, seriously, you would sit here and you think you got them all. And I know you're probably going, man, it's a lot of work just to learn, but there's so many different situations. If I didn't show you all these, then you would be in the dark and wouldn't know what's going on. So here's another one. All right. So first thing is I see a parentheses. So I'm going to distribute first. So we'll put distribute. Let's distribute first. And I'm just going to abbreviate. I'm not in a really hurry to even get it looking nice. Distribute first. So here we go. 3 times 2b. So 3 times 2 is 6b. 3 times a negative 1 is a negative 3 because 3 times 1 is 3 and it's a negative. I don't distribute there because it's not inside the parentheses. So we're just going to put minus 7. This one looks like it's just 6b minus 10. All right. Notice I have 2 of these. These are similar. They're like terms. They're both simple numbers and they're on the same side. I got 1, 2, 3 terms. This one I have 2. So we want to clean this up. So it's 6b. Minus 3 and a minus that's a minus 10. All right, look. Oh my gosh, I can't write today. If you look, aren't these the same already? This is 6b minus 2, that's 6b minus 2. So we're going to keep going. Add 10 to both sides. That's 6b equals 6b because these are a 0 pair and these are 0 pair. Now I got to subtract 6b. When we do, look, I get 0 equals 0. But this time, the variable's gone again. But this time, look, both numbers are the same. This is 0 equals 0. This is another special case. And when the numbers are the same and the statement is true, we say this is all real numbers. So what does that mean? That means you can pick any number, fraction, decimals, it doesn't matter what number you pick, and you put it in here. So we're going to pick, let's pick a simple number. Let's pick 4. Let's just pick 4. All right, so we're going to check it, basically just check. Okay, so 3, 2 times 4, minus 1, minus 7. And then it's going to equal 6 times 4, minus 10. All right, so here we go. 3, that's 8. 2 times 4 is 8. Minus 1 is 7. This is going to be 24 minus 10. That's 14. All right, 21 minus 7, 14 equals 14. So see, it worked. Now see, we could pick another number. We could pick 0. 0, that make it -1. That's a -3, -1, and a -7 is -10. 0 here, 0 times 6 is 0. 0 minus 10 is -10. So see, it works. It doesn't matter what number you use when you do the math. I'm putting combined like terms here so I don't forget. All right, so when you get these are the same with no letter, then you know it's all real numbers. The statement's true. Then it's going to balance every time. You can pick any numbers. That's what it means by all real numbers. It means all the numbers will work. From negative to positive to decimals to fractions, they all work. All right, I have one more to do, and I want to talk to you about this. This is a situation that you're going to see, especially in my class, and maybe even, I mean, I can tell you, you're going to see it on a test too. So let's pretend we have two geometric shapes. All right, one has a side length of 12, the other one's X. All right, and then we're going to say we have another rectangle. One has a side of X minus 2, and then it's got a 16. All right, we need to find the value of X and then find out what the area is. In this case, I'm going to say, let's find the area. Find the area. And remember, area is length times width. That's the area. But before we can find the area, we got to find the variables. This is supposed to be an X. So how do we do it? All right. Well, the area formula is length times width. So that's 12. You got to think of length. 12 times X is 12X. That's the area. This area is going to be 16 times X minus 2. So I'm going to distribute. So it's 12X equals 16X. I gotta forget my X. 16 times 2 is minus 32. I'm going to subtract 16X to both sides. And then we get a negative 4X equals a negative 32. I'm going to change a little color so we can get different colors in here. My variable is X. You can't see. I keep forgetting that I'm not writing. So I'm going to go over this again. So length times width is your area. So the area is your length times width. So you multiply these two. So 12 times X is 12X equals, you got to multiply this length and width. So 16 times that, which I did, is 16X minus 32. All right, then I'm going to move the X's together. So I'm moving the X over there. So the opposite of positive is a negative 16X. So negative 16 here. So 12 minus 16X gives me a negative 4X. The only thing left is negative 32. So I'm bringing it down. Now, my variable is X. What's being done to X? Being multiplied by negative 4. So the opposite is divide both sides by negative 4. So X equals, and you divide that, you get 8. Now, 8 is my X value, right? So I can put an 8 here. Now I know length times width, this area is 96. I can put an 8 in here. 8 minus 2 is 6. 6 times 16 is 96. So they both balance. They're both area. For both of them to have the same area, our X value has to be 8. 8. All right. Hopefully that helps with the variables on both sides. I know it's really lengthy, but like I said, there's so many different ways that things could happen. All right. If you have any questions, give me a holler.